What if AI could do more than just solve problems? What if it could actually improve its own fundamental code and even make brand new scientific discoveries?
That's really the core idea here.
Today, we're doing a deep dive into Google DeepMind's AlphaEvolve. And, well, it sounds pretty revolutionary.
It really is quite something. AlphaEvolve, it's what we call an evolutionary coding agent.
Okay, evolutionary coding agent. What does that mean in practice?
Well, it essentially manages this autonomous pipeline using large language models, LLMs.
Right.
Think of it like a system that constantly works to improve algorithms by directly rewriting their code. It learns from feedback, makes changes, tests them.
Kind of like evolution, but for code.
Exactly. And this process, it's not just tweaking things slightly. It's leading to genuinely new discoveries, both scientifically and, practically.
Okay, genuinely new discoveries. That sounds big. Give us an example. What's something AlphaEvolve did that really stands out?
Well, probably the most headline-grabbing achievement was tackling a problem that had stumped experts for over half a century.
Wow. Which problem was that?
It achieved the first improvement in 56 years on Strasson's algorithm for matrix multiplication.
Matrix multiplication. Okay, I remember that from math class, vaguely. Why is improving that such a big deal?
It's absolutely fundamental. Matrix multiplication is used everywhere: graphics, simulations, AI training, physics, countless fields.
Right. So what did AlphaEvolve actually do?
It found a new way to multiply two specific types of matrices, 4x4 complex valued ones, using only 48 scalar multiplications.
Okay, and the previous best was?
49. It had been 49 since Strasson's discovery back in 1969.
So it shaved off one multiplication. Why is that one step so significant after 56 years?
That's a great point because it seems small, right? But in fundamental algorithms like this, even a tiny optimization gets amplified massively. Think about how many times matrix multiplication happens every second across the world's computers. Saving even one operation, repeated billions or trillions of times, adds up to huge efficiency gains.
Okay, that makes sense. Faster science, more efficient AI, like finding a tiny shortcut that speeds up, well, everything.
Precisely. And it wasn't just that one specific case. It actually found better algorithms for 14 other matrix multiplication scenarios, too.
Incredible. And it didn't stop at optimizing known algorithms, did it? You mentioned scientific discovery.
Absolutely. It moved into pure mathematics as well. AlphaEvolve actually surpassed the state-of-the-art on about 20% of over 50 open mathematical problems it was tested on.
Okay, like what?
One example is improving the lower bound for the kissing number in 11 dimensions.
The kissing number? Sounds intriguing. What is that?
Yeah, it's a classic geometry problem. How many identical spheres can you arrange so they all kiss, just touch a central sphere of the same size without overlapping?
Okay.
It gets incredibly complex in higher dimensions. AlphaEvolve found a configuration proving that at least 593 spheres can kiss the central one in 11 dimensions. The previous known lower bound was 592.
Again, just one more sphere, but I'm guessing that's a big jump mathematically.
A huge jump. It requires finding a really complex, non-intuitive arrangement. It shows the system can navigate these abstract mathematical spaces and find solutions humans haven't.
And these breakthroughs, they have real-world applications too, not just theoretical math.
Oh, definitely. Within Google itself, it developed a more efficient scheduling algorithm for their data centers.
Okay, what did that achieve?
It managed to recover, on average, about 0.7% of fleet-wide compute resources.
0.7% sounds small, but for Google's scale, that must be enormous.
It's absolutely massive. We're talking significant energy and cost savings. It also sped up the training for Gemini, the very LLM that helps power AlphaEvolve.
Wait, so it optimized the training of the AI that it uses itself?
Exactly. It found kernel optimizations that gave it 23% speed up, cutting optimization time from months down to just days. It even helped with TPU hardware design by finding a code change that removed unnecessary bits.
So this isn't just AI solving problems, it's AI improving AI. It's optimizing its own foundation. What's the bigger picture here for generative AI?
That's the really exciting part, I think. AlphaEvolve shows how this evolutionary approach can significantly boost what current LLMs can do. The constant feedback loop lets them self-correct, learn from outputs, and avoid just repeating plausible-sounding mistakes.
So it makes them more reliable, more accurate.
Essentially, yes. It points towards this synergy, AI discovery engines like AlphaEvolve working alongside human experts, but also AI systems getting better at optimizing their own core processes. It's a step towards AI building better AI.
That's a powerful concept. But are there limits? What are the constraints or maybe the concerns with something like AlphaEvolve?
Well, the major limitation right now is that it works best on problems where you can automatically check if a solution is correct.
Machine-gradable problems, you mean, like math proofs or code optimization?
Exactly. Domains like mathematics, computation, algorithm design, where there's a clear success metric a computer can evaluate precisely.
So it wouldn't be great for, say, writing a novel or judging art.
Not currently, no. Those lack this kind of clear, objective evaluation metrics it relies on. However, a key advantage is that its solutions being code or mathematical structures tend to be more interpretable and easier to debug than some other complex AI outputs.
Ah, so you can see how it got the answer.
More easily, yes. That predictability and interpretability are really important, especially if you want to deploy AI in critical systems where you need to trust it.
Right, that makes sense. So wrapping this up, what does this all mean? For you listening, maybe consider this. If AI can now evolve algorithms that stood unchallenged for decades, optimize its own infrastructure, make real mathematical breakthroughs, what other long-standing problems, maybe in science, technology, maybe even your own work, could be reshaped next? Definitely something to mull over.
Thanks for watching. If you found this video helpful, share it with a friend and subscribe for future updates. Looking forward to seeing you in the next one.